Hello, and thanks for clicking on this next Prenarculus production. Today, we're going to be talking about solving trig equations. We're going to use our skills in algebra and our skills on the unit circle to be able to combo those two things and solve trig equations. All right, so let's get started. To solve a trig equation, your goal is to isolate the trig function on one side. You're going to use your algebra skills to do that, and then determine the angles for which the trig function has that value. Okay? So we're going to isolate the trig function on one side. Now, in both of these first two examples, you can see it's by itself. Sine x and cosine x, they're already by itself. All right? Now, we're going to solve each equation on the interval 0 to 2 pi. 0 gets a bracket, it's included. 2 pi does not, which means that if you get any answers that are right here at this point, okay, for your variable, the answer to this problem is 0, not 2 pi. 0 is included, 2 pi is not. All right? So that's how we're going to do this. Okay, so let's talk about example number 1. We got sine x is equal to a half. We'll start easy, and then we'll make it more complicated. All right, our inverse trig function is already isolated. Sine is by itself, sine x. I want to know where sine x is equal to a half. Sine is the y-coordinate. The y-coordinate is positive in quadrants 1 and 2. So we're ready to write down our x values. In quadrant 1, the y-coordinate is a half at pi over 6. And in quadrant 2, it's 5 pi over 6. Those are my two answers. This is all done. Okay. You could also find 5 pi over 6 by doing pi minus pi over 6, right? The reference angle is pi over 6. That would give you 5 pi over 6. Okay, let's try the second one. Cosine x is negative root 2 over 2. So now, cosine is the x-coordinate. The x-coordinate's negative in quadrants 2 and 3. All right. Where is cosine root 2 over 2? Well, that would be pi over 4, but we can't get the answer in quadrant 1. No good. We got to get our answers from quadrants 2 and 3. In quadrant 2, that's 3 pi over 4. In quadrant 3, it's 5 pi over 4. So 3 pi over 4 and 5 pi over 4. Those are our two answers. Okay? It's that simple. As long as you know your unit circle, you're in the game. All right, let's keep going. Now make it a little more complicated. 4 sine x plus 2 equals 0. Okay, so beside each problem, what I'm going to do is I'm going to solve the equivalent to the problem I'm asking you to solve without the trig function. So for example, if I ask you to solve 4 sine x plus 2 equals 0, I'm basically asking you to solve 4x plus 2 equals 0. Well, you could certainly do that. Subtract 2 on both sides and divide by 4. You get x equals negative 2 over 4, which is negative 1/2. So now we're going to do the same thing over here, except we're going to get sine x by itself instead of x by itself. So we're going to subtract 2 on both sides. 4 sine x equals negative 2. Divide by 4. We get sine x equals negative 2 over 4, which is negative 1 over 2. So I want to know where the sine of x is equal to negative 1/2. Well, sine's the y-coordinate. Where's sine negative? The y-coordinate's negative in quadrants 3 and 4. Where's sine a half? Sine's a half. The reference angle would be pi over 6, right, from quadrant 1, but I can't take that answer because it's negative. So in quadrant 3, I'm at 7 pi over 6, and in quadrant 4, I'm at 11 pi over 6. So x would be 7 pi over 6 and 11 pi over 6. And again, you want to get these answers without memorizing it, although at this point you probably know it anyway. You take pi and add pi over 6, that would give you that. And you take 2 pi and subtract pi over 6, that would give you that. Now again, you can't write 2 pi as an answer for these problems for x, but if you want to figure out using the reference angle, you'd do 2 pi minus that to get the 11 pi over 6. And that's okay. All right. Okay, so basically we're going to use our algebra skills to try to get the trig function by itself. All right, let's try 4 tan squared x minus 3 equals 1. Okay, so if I come over here, that's like solving 4x squared minus 3 equals 1. I could do that pretty easy. I'm going to add 3 on both sides. 4x squared equals 4. divide both sides by 4, x squared equals 1, and do the square root on both sides and put plus or minus. So x equals plus or minus 1. Square root of 1 is 1. Okay, I'm going to do the same thing over here, except now I'm going to get tan x by itself. I'm going to add 3 on both sides. So 4 tan squared x equals 4. Divide both sides by 4 to get tan squared by itself equals 1. Take the square root on both sides to knock out the square. I need to put plus or minus with the square root. So I get tan x equals plus or minus 1. Okay, now tangent. Tangent's y over x. Where's the tangent function, positive or negative? Well, it's positive in quadrants 1 and 3, and then it's negative in 2 and 4. So I'm going to get 4 answers to this problem. Okay, 4 answers are going to come up here. 2 positive ones, 2 negative ones. The reference angle is pi over 4, right? Where it's root 2 over 2, root 2 over 2, y over x would give me 1. So pi over 4 is an answer. In quadrant 2, that's 3 pi over 4. In quadrant 3, that's 5 pi over 4. And in quadrant 4, that's 7 pi over 4. And there are my 4 answers to this problem. Okay, let's try secant x times cosecant x equals 2 cosecant x. All right, this one's a little more complicated. There's 2 trig functions, so now I'm going to do 2 different variables. I'll use x for that one and y for that one. So this is like solving xy equals 2y. All right, this is pretty complicated. So I imagine your first instinct is divide by y, but you can't do that. Okay, you cannot divide by y. You cannot divide by a variable in this class. What you could do, though, is you can subtract 2y. You can move that over. And we give you xy minus 2y equals 0. Now, look on the left-hand side. Do you see what to do? We do it all the time. Begins with f, ends with actor. We're going to factor the GCF. So y is my GCF. So now I'm going to split this. It's equal to 0. That's good. So either y equals 0 or x minus 2 equals 0. So I'd have to add 2 to that one. And x would have to equal 2. Okay. So that would be my answer. X is equal to 2. Y is equal to 0. That's a little weird, but that's okay. We're working with these trig functions here. So let's come back up here. And we're going to do the same thing. So the first thing I'm going to do is I'm going to subtract 2 cosecant x on both sides. I can't combine it with that because they're not like. So I have secant x times cosecant x minus 2 cosecant x equals 0. Now there's GCF. Cosecant is in common. I'm going to take out cosecant x. It leaves me with secant x minus 2 is equal to 0. And now, since it's equal to 0 and they're multiplied, I can split them up. Cosecant x would have to be 0, and then secant x minus 2 would have to be 0. So I add 2 on both sides. So secant x would have to equal 2, and cosecant x would have to be 0. Okay, so now, let's do this. Cosecant x being equal to 0. Cosecant is 1 over sine, right? Or 1 over y. Right? But if I take 1 over y, right, as my coordinate, how am I going to get 0? If I do 1 over 0, it's undefined. Okay? Or, that's one way to look at it. The other way to look at it is this. Cosecant x is 0 over 1. If I flip that over, that would mean sine x would have to equal 1 over 0. So sine would have to be undefined, but sine is never undefined, right? We never get undefined for sine. So this has no solution. There's no answers from this at all. Cosecant x equals 0. It doesn't give me anything for x. But secant x equals 2, that looks pretty possible, because that would mean cosine x would be a half. So cosine's positive in quadrants 1 and 4. And then cosine's positive in 1 and 4. Where's cosine a half? Pi over 3. And down here, it would be 5 pi over 3. So my two values for x would be pi over 3 and 5 pi over 3. And then over here, this cosecant x equals 0 doesn't give me anything. So I only get two answers from this. Both of them come from this factor here that I solved. Okay, and that is possible. Some of these trig functions won't give you any answers. All right, let's try one more. So this one is probably the most complicated one of all. 2 cosine squared x plus 7 sine x equals 5. Well, we got a big problem here because I'm asking you to solve 2x squared plus 7y equals 5, right? These variables, they're not even the same. All right, so cosine and sine, they're totally different. So I got to call 1x and 1y. So this is a quadratic equation with two variables. One equation, two variables. I can't solve that, right? We can't work with that at all. Okay? You can't solve this for x or for y. And you can't bring the 5 over and factor it. That doesn't work. So what are we going to do with it? Well, what we're going to have to do is somehow we're going to have to change one of these trig functions to be the other one. So I need some way, some identity to change one of these two into the other. Well, I know something about this cosine squared here. I know that sine squared plus cosine squared is equal to 1. And I know then that cosine squared is equal to 1 minus sine squared. So I could take out the cosine squared and put a 1 minus sine squared in its place. And that's what I'm going to do. Okay, now how does this help me? Well, the first way it helps me is that at least now I have one variable, right? I have like y's for everybody now. Sine is the only thing. So 2 minus 2 sine squared x plus 7 sine x equals 5. So that's like me asking you to solve 2 minus 2, I'll use y squared plus 7y equals 5. How do I solve something like this? It's quadratic. How do I solve any quadratic? I move everything over to the same side and hope I can factor it. Well, that's what we're going to do. So I'm going to move the negative 2. I'm going to move everything on the left over to the right-hand side only because the y squared here is negative and I'd rather it be positive. I'd rather work with that. So I'm going to subtract 2. I'm going to add 2y squared, and I'm going to subtract 7y. So that would give me 0 on the left. On the right-hand side, I'd have 2y squared minus 7y plus 3, if I write it in order. Okay, now I got to try to factor this. 2y squared plus 7y, or minus 7y plus 3. It's AC, slide and divide, or guess and check, one of them. So I can do that. I use guess and check, but you could do slide and divide or AC, whatever makes you happy. 2y and y. I need to make this a negative 3 and a negative 1 because that's negative 6y, that's negative 1y, that's negative 7y. Negative 1 times negative 3 is positive 3. So that works. Good. So then I can split these and solve them both. So 0 equals 2y minus 1, and then 0 equals y minus 3, y equals 3. And then y equals 1/2 over here. Add 1, divide by 2. Those would be my two answers. All right, so now I'm going to do the same thing over here with this disaster. I'm going to subtract 2 on both sides. I'm going to add 2 sine squared, and then I'm going to subtract 7 sine. So that would give me 0 equals 2 sine squared x minus 7 sine x plus 3. All right, now I got to factor this. So I'm going to factor it literally with the signs in there. You can do that. It doesn't make a difference. So normally we would write y and y or x and x. You could just write sine x. Okay? So it factors the same way we just factored the other one over here. So I get 2 sine x minus 1 times sine x minus 3 equals 0. So now I'm going to split them both and solve them both. So I have 2 sine x minus 1 equals 0. And sine x minus 3 equals 0. So sine x will have to be 3, or sine x will have to be 1/2. All right, let's deal with the first one first. Sine x is 1/2. Sine is positive in quadrants 1 and 2. Sine is a half at pi over 6. And then over here at 5 pi over 6. That's two answers. Pi over 6, 5 pi over 6. Now, let's go to this one here. Sine x equals 3. Oh, wait a minute. Sine x equals 3. That's not on the unit circle. Not only is it not on the unit circle, the biggest sine x is ever going to be is 1, right? Because on the unit circle, the radius is 1. You can't get any bigger than that. And sine's the y-coordinate. The y-coordinate's never bigger than 1. So this is garbage. Okay? It doesn't give you a solution at all. So there's only two answers to this, pi over 6 and 5 pi over 6. So we have a lot of stuff to think about, a lot of stuff to work with. You got to know your algebra. And now it looks like you also need to know your trig identities. Okay? And you got to know your unit circle. All right? And as always, thanks for clicking.